Welcome you all for today's lecture on concrete technology. This is video lecture 3, which is the first lecture in unit 2. By the way, this is Mr. K. Venkatesh, Assistant Professor, Department of Civil Engineering, KLG Mtb University. So, in unit 1, I have seen about the cement, and then about the testing on the cement, the types of cement, everything I have seen in unit 1. So now this is the introduction about unit 2, which is aggregates and testing of aggregates. So in unit 2 we are going to learn mainly the classification of the aggregates based on their size, shape and texture, and also based on their strength and bulk density and specific gravity. So once you complete this classification in video lecture 1 of unit 2, we'll move to video lecture 2 of unit 2, that is measurements of moisture content of aggregates and testing of aggregates, and also we will see about the water in concrete. So this unit 2 contains the 2 video lectures. The first deals with this classification and the second deals with the testing of aggregates and measuring the moisture content of aggregates. Now we will start with the classification of the aggregates. So this is unit 2, aggregates and testing of aggregates. Now here there are so many types of aggregates are shown. You don't know the type of aggregate here, but you know the sizes of the aggregate. By seeing the aggregate sizes, you can able to differentiate normally. Without knowing the size itself, you can differentiate. This is a small size and this is a small, somewhat larger size compared to the first one. Sorry. And this is larger and compared to this. Like that you can able to see from these figures. So how can you differentiate a particular given aggregate? That differentiation of aggregates is mainly based on their sizes. So normally the stones, what we are calling it as aggregates, is a combination of different sizes and shapes. So the sizes can be of different, which are, for example, 0.15 mm to 0.3 mm. This is one type of aggregate, and this is 0.3 mm to 0.6 mm. This is one more type, and this is 0.6 to 1.18 mm. And these aggregates are of size 1.18 mm to 2.36 mm. And these aggregates are of size 2.36 to 4.75 mm. And these are of 2.36 mm to 4.75 mm. And these are 1.18 mm to 2.36 mm. Like that, there are so many types of sizes in aggregates. And also, if you can able to observe here, each aggregate is of different sizes and different shapes. So this combination of different sizes and shapes making a different number of stones. So what is the maximum size of the aggregate that is possible here? The construction is 75 mm. That is an aggregate of maximum size. So you might be thinking there are aggregates which are greater than this, but these are not used in the construction purposes, where 75 mm could be the maximum value. So this is about different sizes of the aggregates. Now we will see what are the uses of these aggregates, and then we will go with the classification. So what are the uses of the aggregates? So without aggregate, how can you produce in a concrete? So in a concrete, we already discussed the basic parts of this concrete are cement, and then water, and the next most criteria is aggregates. So aggregate could be of fine aggregate or coarse aggregate, that we will discuss in the classification, but their uses in preparation of a concrete is very higher. So this is used as an ingredient in Portland cement concrete and also asphalt concrete. This is one of the major use we are saying. And also these aggregates are used as a underlying material for foundations and also in pavements. Pavements in the sense of the roads. It could be bituminous roads or concrete roads. So there also we are using an aggregate, and also in foundation works. So below your superstructure there is a substructure that is called foundation. That foundations also we are using these aggregates. So these are the main uses of the aggregates. Now, how can you select these aggregates? The selection of aggregates depends on so many parameters. So what are the parameters that you need to choose while selecting an aggregate type? So the aggregate shall be hard, means you need to make sure that the aggregates whatever you are using should be hard, and also durable. Durable in the sense it should last for a long time, means the lifespan, and the aggregate should be clean enough. There should not be dust, there should not be any organic material on the aggregates, and it should be free from adherent coatings and organic matter, which makes that it is a clean now again. It is something related to clean again. And it shall not contain the appreciable amount of clay. It can contain amount of the clay, but it should not be more than, some limits are there for the clay, so it should not be more than that. And also the main thing that we need to consider while selecting the aggregates is the harmful impurities, such as iron pyrites, alkalis, salts, coal, mica, shale, or other materials which will affect hardening and attack the reinforcement of the structure. So these harmful impurities should not be there in the aggregates. So you need to make sure that while selecting an aggregates, so all these properties are there in the aggregates. In the next slide, we will see the classification of aggregates. From here we will start main classification of an aggregate. So the classification of aggregates is based on so many parameters. So among them, the first one is based on their sizes. So this could be the major criteria in classification of an aggregate. So based on size, these aggregates are classified into two types. One is fine aggregate and the second one is coarse aggregate. Now we will see what do you mean by fine aggregate and what do you mean by coarse aggregate. Fine aggregates are nothing but the aggregates which pass through 4.75 mm sieve. So here you might be hearing this sieve so many times. So in a lab, what is happening is there are so many number of sieve sizes. So something like tray, they are looking like a tray shape. Sieves are there, so of different sizes. It could be 75 micron sieve, 4.75 mm sieve, 2.36 mm sieve. There are so many number of sieves are there. So in that, the primary sieve that we are considering is 4.75 mm. So if the aggregates are finer than this size, means they can able to pass through very easily through this size, right? So that type of aggregates which are finer than 4.75 mm sieve are called fine aggregates. So I can say this sand which is finer than 4.75 mm. Suppose in that sand itself some particle might be greater than 4.75 mm, which are not considered here as a fine aggregate. So or else we can say the aggregates with the size less than 5 mm are also called as fine aggregates. Coming to the coarse aggregates, so it is reverse of fine aggregate, where if the particles or the aggregates are of size greater than 4.75 mm, so greater than 4.7 mm, 4.75 mm in the sense they cannot able to pass through this 4.75 mm. They can able to retain on this sieve itself. So they can retain here. They can't pass through this sieve. So those type of aggregates are called coarse aggregates. But we said they have to retain on 4.75 mm. But beyond this, there are so many sizes are possible. So all of them are also coarse aggregates. Is there any limit? Yes, there is a limit. That is 75 mm sieve. So the aggregates between 75 mm to 4.75 mm are called coarse aggregates. Means they have to pass through 75 mm sieve, but they have to retain on 4.75 mm sieve. So those are called coarse aggregates. You see here, these are coarse aggregates. So also we can say these aggregates with the size greater than 5 mm are also called coarse aggregate. So this is a simple classification of an aggregate, which is based on the size of an aggregate. The next one is the classification of aggregates based on source or method of manufacture. This is also one of the best method for classification of an aggregate. So this is again broadly classified into two categories. One is natural aggregate or uncrushed aggregate. We can call with any of these names. Natural aggregate or else also called uncrushed aggregate. And the second one is manufactured aggregate or else we can call it as a crushed aggregate. So these are the two classifications under source or method of manufacture. So where natural aggregate or uncrushed aggregates are the aggregates, those are from river beds, river sand and X mines. Normally these natural aggregates are round in shape and they have very smooth surface texture. Coming to the manufactured aggregate are also crushed aggregates. These are the aggregates which generally obtained by mechanical crushing of the rocks. If you take a rock and crush them into pieces, the aggregate that we are obtained is called crushed aggregate, or also called manufactured aggregates. So no need of only crushing the aggregates. You can also crush the boulders or cobalts, so which are very larger in size. So if you crush them, you will get an aggregate of required sizes, which are called manufactured aggregates. Normally, these crushed aggregates are not in round shape. They are generally in angular shape. And also, their surface structure is not smooth, rather it is very rough. So that is the difference between the natural aggregate and manufactured aggregates. So this is the classification based on source or method of manufacture. And the third classification of an aggregate is based on density. So you know the density? Density is nothing but mass by volume. So there is unit weight of a material, which is notated with gamma, that is weight by volume. So here the classification of aggregates is based on their density. So some aggregates, we will test the aggregate and we will find out what is the unit weight of an aggregate. So that we will see in the video lecture 2 of unit 2. So how to calculate the density of an aggregate. But for time being, we are saying here the classification of an aggregate based on their density is of three types. One is lightweight aggregate, normal weight aggregate, and heavyweight aggregate. We will see the detail about lightweight aggregate and normal weight aggregate and heavyweight aggregate in next slides. So this is the classification of an aggregate based on their density. So now let me give a brief introduction about the aggregates which are divided based on their density, which are normal weight aggregate, lightweight aggregate, and heavyweight aggregate. So here in this slide we will see what we mean by normal weight aggregate. So normal weight aggregate is an aggregate of crushed stones, gravel, or ordinary sand. So I can say all these three are examples of normal weight aggregates. So they are very commonly used in manufacturing of normal weight concrete. That is, these normal weight aggregates, which are crushed aggregates, gravels, and ordinary sand, they are used in preparation of the normal weight concrete. And also they can be used in preparation or manufacturing of asphalt concrete, and also they can be used in roadway subbases also. And if you take the specific gravity values for sand and gravel, which are about 2.6 and 2.65 respectively, that is, specific gravity for sand is 2.6 and the specific gravity for gravel is 2.65. And if you consider the bulk density of the normal weight aggregates, I said already there is a unit weight measurement for aggregate, which is nothing but weight by volume. So this bulk weight of the normal weight concrete, so normal weight aggregate, is around 1520 to 1680 kg per meter cube. So this is kg per meter cube is the units of unit weight, that is weight per volume. So this is about normal weight aggregate. Now we will see what do you mean by lightweight aggregates. So the name itself is saying that the aggregate is very, very lightweight. That is, this produces a lightweight concrete. Since the aggregate is of very lightweight, it produces a very lightweight concrete. So if I classify this lightweight aggregate, aggregate can be fine aggregate or coarse aggregate, right? So in that fine aggregate, which is lightweight fine aggregate, is having a bulk density which is less than 1120 kg per meter cube. So this is the density of lightweight fine aggregates. Likewise, if you consider a coarse aggregate, this coarse aggregate is aggregated with a density less than 880 kg per meter. So this is the density of lightweight coarse aggregate. And you can find that here the lightweight fine aggregates is having more bulk density when compared to the lightweight coarse aggregates. So these aggregates are commonly used for manufacturing of the lightweight concrete. So not only in lightweight concrete, so for making the lightweight masonry blocks, you might have seen RC blocks outside. So, and also the masonry blocks, all these are manufactured with the use of lightweight aggregates. So what will be the benefit if I use the lightweight aggregate? The first criteria is, as I am using a lightweight aggregate, so the weight of a concrete is reducing. When I say the weight of concrete is reducing, internally what is happening is the dead weight of structure is decreasing. That is, the dead weight, in the sense the dead load of a structure is decreasing. When the dead load of a structure is decreasing, the amount of concrete that is taking place inside that element, that structure, is less. Hence, the cost of the structure is decreasing. So, at the end, we are reducing the cost of a structure with the help of lightweight aggregates. But we are not losing the required properties of concrete, which is strength, stability, and stiffness, and also the durability. All these properties are not missing, but still we are getting the lightweight concrete, hence it is more economic. So it mainly improves the thermal resistance also. The thermal capacity of the structure can be a masonry block, can be an RC block, can be a concrete. So in every case, the thermal capacity is increased. And also the lightweight floors and lightweight roof slabs are also made with the help of these lightweight aggregates. So these lightweight aggregates are normally of two types. One is natural lightweight aggregate and manufactured lightweight aggregates. If you see the natural lightweight aggregates, the examples for natural lightweight aggregates are the palm oil shell, means the shell that we are having for the palm oil, coconut for example. Those type of shells are lightweight aggregates. And also rice husk, which is a natural lightweight fine aggregate. This is a fine aggregate, and this could be a coarse aggregate. And also the manufactured lightweight aggregates, which are also called the synthetic lightweight aggregates, I could say. So these are the types of the lightweight aggregates. Therefore, these lightweight aggregates are much using nowadays in the preparation of a concrete. So with the reasons for making the lightweight aggregates are the cost of the structure is decreasing by reducing the dead load of the structure, and also the thermal capacity and the strengthening properties of the concrete is improving. And also these lightweight aggregates are used for preparation of lightweight floors and also in roof slabs. So this is about lightweight aggregates. In the next slide we will see the heavyweight aggregates. So here in heavyweight aggregates, so it is quite opposite of the aggregate which we have studied in the previous slide, that is lightweight aggregates. Here the aggregates are of very heavy. So these aggregates having a very high density, since because they are of very heavy weight, their density is very high and used primarily in the manufacturing of heavyweight concretes, and it is employed for protection against nuclear radiation and as a bomb shelter. If you consider the unit weight of heavyweight concrete, which is varies from 2400 kg per meter cube. This is normally the weight of unit weight of normal concrete. So the unit weight of this heavyweight concrete, which will be beyond this value, beyond 2400 kg per meter cube. And if you see the specific gravity of this type of concrete is varies from 4 to 4.6, which is very high. So if you consider normal aggregates, if you take a fine aggregates, for example sand, it is of specific gravity 2.6. If you consider the coarse aggregate, for example gravel, that is of 2.65 specific gravity. But here if you consider the specific gravity, it itself is ranging from 4 to 4.6. It can be a fine aggregate or coarse aggregate. It varies between 4 to 4.6. So what are the examples for that is the mineral ores and barite. These two are the examples for the lightweight aggregates. So with this we have completed the heavyweight aggregates. So if I briefly introduce again about the heavyweight aggregates. So this is the one which is having the specific gravity between 4 to 4.6. For example, mineral ores and barites. And these aggregates are used in order to produce heavyweight concrete. Hence, these are mainly used for preparation of the heavyweight concrete. So, these aggregates are of very high density and used primarily in the manufacturing of the heavyweight concrete. So, what is the application of these heavyweight aggregates is, these are used and employed for the protection against nuclear radiations and as a bomb shelter. So these are the main applications of the heavyweight aggregates. So with these three types of aggregates, that are lightweight aggregate, normal weight aggregate and the heavyweight aggregate is completed. So with that, the basic classification of aggregates which I had mentioned before is completed, which are based on the size, the first one, and based on the source and method of manufacturing, the second one, and the third one is mainly based on the density. So with this, the classification of aggregates is completed. So in the next slide onwards, we will see the physical properties of an aggregates, which are mainly the strength, hardness, toughness, durability, porosity and water absorption. So all these properties of the aggregate we will discuss in the coming slides. The physical properties of aggregates. The first one is the strength. We will see the strength first, and then remaining things we will see in subsequent slides. The strength of aggregate. So before using any aggregate in concrete or in any other application, first foremost criteria that you need to check is the strength of aggregate. So in practice, majority of the normal aggregates are considerably very stronger. So this is a normal statement which is saying that majority of the aggregates are of stronger compared to the concrete. But how can you say the particular aggregate is stronger? How can you measure its strength? For measuring the strength of aggregates, we have so many tests that to be performed in the laboratories. We will see the strength tests of aggregates in the video lecture 2 of unit 2, testing of the aggregates. Now here we are simply giving a basic idea about the strength of aggregate and what should be the minimum value for the aggregates to be used in the practical applications. A good average value of a crushing strength of aggregates is 200 megapascal. So if you consider any aggregate, that should be minimum 200 MPa strength, crushing strength, then we are calling it as a good aggregates. So that this type of aggregates can be used in the construction purposes. So this is about the strength of aggregate. So next one is the hardness of aggregate. The hardness is nothing but the resistance power of an aggregate without imparting any indentation on the surface of the aggregate. That is nothing but the hardness of aggregate. So the hardness of aggregate, I can also say the ability of the aggregate to withstand or wear or load applied pressure. So if the aggregate can able to withstand the applied pressure or applied load, so without failing, without any indentation on the structure, then it is called hardened aggregate. This hardness is depending on the type of parental rock. Since you might be producing these aggregates from the manufacturing, that is the crushing of a parental rock into small segments where you are getting the aggregates. So the hardness of an aggregate will depend on the hardness of the parent rock first. If the parent rock is of good hardness, then you can expect the crushed aggregates from the parent rock are also having the same hardness. And the test that can obtain the hardness is abrasion test. This is a test that you need to perform on the aggregates to find the hardness of the material. We will see how this test is to be performed in the coming modules. After performing this abrasion test, so what should be the minimum value that you need to get which justify the hardness of an aggregate? That depends on the application where you are using these aggregates. For example, if you are using any aggregate for wearing surfaces, that is, suppose you are constructing any road, on the road the top surface is called wearing surfaces, which you can say the bitumen, in that bitumen also you are using some aggregates. So for these type of wearing surfaces, what are the aggregate that you are using? That should have an abrasion value not more than 30%. And also, if you use these aggregates for non-wearing surfaces, means suppose if you are constructing a road, there is a 3-4 layers are there. For example, this is subgrade, and this is subgrade, for example, and this is a subbase, and this is a base course. On the top of this, there is a wearing course. So this is about transportation engineering. This is also one of the branches of the civil engineering, where you will get to know how these particular roads are constructed. So these layers of the roads are classified like this. This is a subgrade, and this is a subbase, and this is a base, and this is a wearing course. For the top wearing courses, whatever the aggregates that we are using, that should have abrasion value not more than 30%. And if you are using this for non-wearing courses, for example, any of these layers, it can be a base or subbase or the subgrade or any other layers, the abrasion value should be 50%. It should not be more than this value. So now we will see this abrasion test very clearly in the testing of aggregates, which is lecture 2 of the unit 2. The third property of an aggregate is the toughness. Toughness is nothing but the resistance of an aggregate to failure by sudden or impact loading. Means if you apply a sudden load or sudden impact load on aggregate, how much resistance it is having without the failure of a material. So that defines the toughness of a material. So the toughness of an aggregate can be determined by using the aggregate impact test. This impact test we will see in testing of an aggregate in unit 2, video lecture 2. But here I am giving the values, the minimum values for the aggregates to get the toughness. The aggregate impact value shall not be exceed 45% by the weight for aggregates to be used for concrete purposes. Means if you are using any aggregate in the concrete, it should not have the strength, that is the impact strength should not be more than 45% by the weight of an aggregate. Likewise, if you are using these aggregates for the wearing surfaces, as I mentioned in the previous slide about the wearing surfaces, in those cases this aggregate impact value shall not exceed 30%. So these are the minimum values for the aggregates that to be considered when using these aggregates in the practical applications. So we will get to know much detail, and these ratios and these percentages also much clear in the testing of aggregates. And the next one is the durability of an aggregate. I said already, the durability is nothing but the lifespan. The lifespan of an aggregate means how much time this aggregate can last without any failure. So if I give a clear definition, it is an ability of an aggregate to withstand external or internal damaging or attacks on the structure. So this is what is durability of the aggregate. In simple terms, it is a life of an aggregate. The durability of aggregates can test using soundness test. So I will explain much clearly about the soundness test for getting the durability of an aggregates in aggregate testing. But here simply I am giving the physical property of an aggregate should be also a durability, which is the resistance capacity of the aggregate without failure for longer period. So in the next slide we will see the porosity, which is also a physical property of aggregates. Porosity is nothing but, generally the porosity is a term which is notated with eta, that is N, this is porosity, which is defined as the volume of voids by the total volume. So this defines the porosity of soil. So as the soil is having the porosity, pores inside it, this is for soil structure, this is for soil. So the aggregates are also having some pores on it. These pores are of various sizes. So this aggregate will absorb the water when it is dry, but normally release the water in the concrete mix when it is wet. So this is the one beautiful property of an aggregate is, since the aggregate is having the voids inside it, it will absorb the water whenever the aggregate is in dry condition. But when this aggregate is placed in a concrete mix, so it releases the water when it is in wet condition. The amount of water and its rate of permeation depends on the size and volume of aggregates. Means the amount of water that goes into the pores, since the aggregate is containing a pores like this, so as there is a pores spaces, so the water can enter into these pores. This size, the amount of water and its rate of this permeation depends upon the main size of aggregate and also its volume. Since the aggregate comprises 75% of the concrete volume, this we already mentioned that aggregates occupies most of the volume of concrete. That is, it occupies 75% of the concrete's volume. As it is occupying this much percentage of the concrete volume, it is very essential to note that the porosity of aggregate contributing to the overall porosity of the concrete. So what this statement is saying that, since the concrete is also having, if this is a concrete, this concrete is having so many ingredients inside, and hence will produce a concrete structure. In that concrete structure, there are so many pores on that. So here, these many pores which are coming on this concrete are mainly the contribution of the aggregates. Since the aggregate is 75% of the concrete volume. That's why the porosity of a aggregate is the most physical property that to be studied while using these aggregates in the concrete. With that, the physical properties of the aggregates is completed. In the next video lecture, that is Unit 2, Video Lecture 2, we will see very clearly about how to measure the water content, moisture content of an aggregates, and how to test the aggregates, which are abrasion test and also the impact test, and how to find the specific gravity of the test of the aggregates. All these things we will discuss in the next video lecture. Thank you very much, and will you meet you again in the next class.